get us back to this screen, this one. Hello, everyone, and welcome to another episode of Learn with Jason. Today on the show, we are going to be learning about a bunch of stuff that I keep hearing the names of and have no idea how to use. And to help us, I'm bringing on a previous Learn with Jason guest and friend, Adam Cowley. Adam, how you doing?
Hello, I'm good. Yeah, good. Glad to be here. How are you?
I'm doing so good. I'm so excited because I feel like I've spent a significant amount of effort trying to ignore AI, just in general. I was joking with you beforehand that like there are certain fields where I just start to get the like, I don't know about this one. It feels like people are making some big promises, and that probably means that in another few years we'll forget about it entirely. But something feels different about AI because I'm actually seeing it get used in different medium. However, before I dive into that, because I have a million questions for you, let's start by setting some context. So for folks who aren't familiar with you and your work, can you give us a bit of a background?
Yeah, sure. So, my name is Adam. I'm a member of the developer relations team at Neo4j. I've been at Neo4j as a company for about 8-9 years now. So Neo4j is a graph database company. We represent data in nodes and relationships. We excel in the connection between those things. My day job is to educate people, educate developers in how to use Neo4j, and I do that through our online platform, which is called Graph Academy. So I think for the past three or so years, I've been producing courses for there and like trying to provide a hands-on experience. But I want to say I'm a developer first, and I don't even really want to talk about Neo4j today. So like Jason, keep me honest today. We're here talking about GenAI. If anybody hears me mention Neo4j out of context, just like let me know. Like put a boop in the channel, something like that, and I will send you a free T-shirt. Adam@neo4j.com. Like keep me honest. Listeners, yeah, this is not a sales pitch for Neo4j, I promise.
If anybody does it, I'm ready with the soundboard. We'll just blast it. All right, so I want to. Adam Argyle is here to challenge you for the right of the only one Adam.
There's always two Adams, no matter where you go.
That's true. Yeah, that actually is true. Like Adams and Mikes, there will always be in any gathering of 3 or more people, at least 2 Adams and at least 2 Mikes. Do that math. So Adam, let's talk a little bit about AI. So there are, I think, all right, so let me start by attempting to set the context for what I understand, and then you can set me straight on this. AI, as far as I can tell, is a buzzword for literally anything that's being done right now with like machine learning or computer vision or all of these things that have sort of been around for a long time, but we just collectively discovered a lot of hype for them and have bundled them up under the term AI. And then there is a subset, I think, of AI that has been called GenAI, which is short for generative AI. Is that correct?
Yep. Yeah, that's right.
Okay. And generative AI is something I don't understand because whenever you start reading about it, it includes a bunch of things that are net new information to me. Like I don't know what a vector database is. And whenever I start reading about, GenAI or something like that, it kind of immediately starts hitting me with like, well, yeah, so in GenAI, you're going to use this set of vectors and you're going to do this. And I'm like, I don't know what any of this means. So I just sort of back away slowly. And as a result, I haven't really learned anything about it. So, in your experience, like, am I correct in saying that AI without prefixes or qualifications is just a marketing word? Is that a safe assumption?
So not necessarily. So I guess like when people talk about or when people are talking about like AI in general, what they're getting towards is AGI, like artificial general intelligence. Mm-hmm. Which we're not quite there yet, but so you have machine learning, which is you take data, you train a model to predict something or to do something, and then you get an output from that, and then artificial intelligence is applying that, so the decisions get made for you. these signals get acted on. So that's kind of the difference between machine learning and AI in general. And with generative AI, like you can genuinely call it AI, artificial intelligence, because you're having something act on something without any human intervention. But really, what GenAI is generating content or generating something based on instructions, based on a prompt.
Okay, and so this would be, I guess, ChatGPT being the most famous example here. Is that is GenAI?
Yeah, and so this is nothing new really, because like these models, so like the GPT is the type of model that is used. So I always forget this, but it's generative pre-trained transformer. So it's a category of model, machine learning model that it's basically trained on like a vast amount of data, and then this basically turns into like a next word generator. But it's a way of predicting what the next word would be in a sequence, and then kind of keep doing that until it runs out of juice.
Got it. And so this is, there have been concepts like this for a long time that are obviously a little less sophisticated, but things like a Markov chain have been around for a very long time. And you get, I think that's why predictive text on phones is so funny, is because there's sort of I don't know if it's exactly a Markov chain, but it's something like that it's like, in relation to the word that is before it makes sense, but like in relation to 5 words back, it definitely doesn't. And that's why those tend to be pretty funny sentences if you just start tapping the auto generate. And so the idea of something like ChatGPT is that it's sort of taking that to a much more sophisticated extent, right? Where I can expect that I should expect coherence, like not just based on the previous word, but on like the context of what's being said. It should all feel like a real thought out sentence.
Yeah, and that's where, I mean, we'll get onto it, but that's where kind of like the vector embedding, semantic search, and things come in. But yeah, the reason why this is so big at the moment, and the reason that, I mean, because like if you think of like the big explosion came with like GPT-3, and that was when people started to kind of pay attention. But like these models have been around for ages, but the reason that ChatGPT really took off was because it was easy to use. There was this chat interface, and then you could interact with this model through just a text box. And then it did amazing things that you would have to do with I don't know, like some sort of command line interface or some sort of API, something that's kind of hidden away from like the execution of it. So yeah, that's kind of where we are.
Got it. Okay, so before we get too deep, let's do a little bit of like a glossary up front, because there are going to be a lot of new concepts, and I just want to make sure that I understand what they are. So we've defined AI in general. We've defined GenAI. You said vector embeddings a second ago. So what are vector embeddings?
In a nutshell, a vector embedding is an array of floats between -1 and 1, which represent the distance between a chunk of text or a concept and certain items that the LLM will deem to be important to kind of be able to understand what the thing is. So you essentially take some text, pass it through to an embedding model, and then you get back a series of numbers, essentially.
Okay. And so that sounds like math. And so from a practical standpoint, what is that math doing?
So that is, it's basically a distance between something, or the concept or the chunk of text that you have, and certain other concepts. So you can kind of gain the like based on these numbers, and like we're never going to know what these numbers are, why a certain number is 0.1235, but it's kind of the distance between something and something else, like a concept. and then you do like it's based. So it's you do like a cosine similarity or some sort of similarity comparison to work out two things that are similar to each other.
And so this is sort of like the idea of if you were, like in UX, for example, when you're trying to map out the navigation for a really big app, one of the exercises that they'll have people do is they'll take all of the concepts in the app and then do a card sort where they start like grouping them together based on like what somebody thinks they are. Like, I think this is like this and I think this is like this. And that helps create sort of a conceptual map or a conceptual overview of how the app is perceived by somebody else. And so in a very rough analogy, what we're doing is we're basically saying, hey, whatever model we're using, build your own like conceptual map of the information that I've just put in, so that if somebody asks you a question, you're using this set of data to make decisions about how to respond, as opposed to just like guessing at random.
Yeah, and this is on a grand scale as well. So you're talking, 1,000 plus dimensions, or a 1,000 plus dimension space where each of these distances is a distance from something else.
Gotcha. Yeah, and then Jem in the chat is saying, a strawberry is closer to fruit, further from building. I think so. That makes sense. Obviously the examples that we're using here are very oversimplified, but that is, I think, a very. It feels very intimidating, but when you talk about it, it really is. We're just trying to emulate the way that humans like categorize things, because when we look at anything, we're instantly categorizing it on a ton of different vectors, to use the word, where, when you look at a piece of fruit, you think about the color, you think about its location, you think about its size, you think about its, like, what is it similar to, what is it not similar to, what does it taste like, all those sorts of things that are very, we just do it, right? But if you were to try to build a software application by hand that could do all of the same categorization as like a human brain does, it immediately gets unwieldy to try to like write down all of those things and predict. This is why building software is such a challenge, is that you're always trying to predict what other humans will want, and it's just very, very, very hard to do that. So maybe this is where the excitement comes from, is that these models theoretically close that gap, where if we have the available information, the model then theoretically can present it in a way that no matter how somebody asks the question, it can sort of understand what they meant and give them what they intended, as opposed to me as a developer having to predict exactly how somebody might try to surface that information.
Yeah, definitely. Yeah. I mean, if you take, strawberry is a good example. The example that I use as well is like Apple. So we've got Apple the fruit, and we've got Apple the company, and based on the kind of the words around, like the context of the sentence, those two are two completely different things. But
Right.
based on the kind of semantics of the sentence and the distances from these concepts in the embedding, means that you can work out like semantically, like whether this thing you're talking about is the fruit or it is the company. And that's something that it has always been difficult to kind of understand in terms of like NLP or natural language processing or entity recognition, stuff like that. This is a difficult thing that you've almost got a silver bullet for. Like it can, you can figure these things out with these vector embeddings.
Got it. Okay. So that's what a vector embedding is. Any other big concepts that we're going to need to be familiar with as we dive in here?
None I can think of off the top of my head. I think we'll
okay. So we'll tackle them along the way. Yeah. All right. Now, before we start, there's one other thing that I want to address, which to me is kind of the elephant in the room with AI, and I talked about it a little bit at the beginning of the show, but to me, AI, when it first came out, had a very similar sort of smell as a lot of things that have kind of over time proven to be a bit overblown. We see the sort of get rich quick gold rush of people everybody's trying to say, oh, we're this kind of company now. We offer we've got that tech, we've got that tech. And AI very much has that happening right now, where it seems like every single company is in a dead sprint to add something that counts as AI so that they can say, yeah, we do AI. Historically, like with crypto, that ended up being a pretty massive distraction that's had a fairly low long-term impact on anything. Like, we're not seeing a lot of the Web3 NFTs, those sorts of things. Like, they're still around, but they didn't have the government's not using crypto, our banks aren't using crypto. We didn't really see this massive change. It was technology, it's cool, but life goes on, right? AI is being touted in the same way. Like, it's going to change everything. It's going to replace developers. It's going to replace every job. Actually, it's just going to be, it's all we've even got things about the Rocco's basilisk thing, which I'll let y'all Google on your own because it's very funny.
What was that? Sorry?
Rocco's basilisk. Let me. I'll drop a link in. Because it's too much of a rabbit hole to get into right now, but it is a very fun little side quest for anybody who wants to go down the AI rabbit hole.
I'll close my browser. I won't be reading it while you're talking.
Much appreciated. But so what about AI is hype? And what about AI is real? And I'm just gonna preface this for everybody with, this is two dudes having opinions. This is not take it all with a grain of salt and come to your own conclusions here.
Yeah. So my experience is nothing is ever as easy as people make it out to be, and we'll probably cover that. Find a few examples of that. If anyone tells you that they've made thousands of dollars on doing one thing, it's not happened. Also, to a certain degree, if there's a video on YouTube that's got somebody looking shocked, probably not. You're probably not going to make any money off of that. But I think the difference that I see between this and other things is that you've got real life kind of uses and applications. I guess with Web3, it's a great idea and it's an ideal, but I can't see the application there. Whereas, depending on what industry you work in and what you do for a living, there are applications across across the industries, really. I've used it for quite a few things, failed with it quite a few times, succeeded a few times as well. I think that there's always that degree of skepticism. I think that's right. But there's also that kind of degree of what's the word? I guess people will be scared of it, but then people were kind of scared that when cars first came out, that if they went over 5 miles an hour, then your head would spin, or women can't drive cars because it will rotate their ovaries, or all that sort of stuff. And then there are also the people that are have the vested interest, the horse breeder that doesn't want cars to kind of take off as well. So yeah, there is that, but I think there's also the optimist side of it, where with these new advances in technology, instead of being kind of scared of things going wrong and AI is going to take all our jobs, right now it definitely won't, and I can promise you that, because I've tried to make it take my job and I'm getting nowhere with it. There's applications that you can kind of take to that you can kind of do with it. And I think it's all about freeing up people to do more interesting things. So I'm thinking, if this can take my job, I can perfect my pizza dough recipe. And I guess you probably focus on burgers or something, right? There's other things we can do.
Yeah, and I think there's a very philosophical discussion to be had here, and I saw Nicole Sullivan was talking about this, where the promise of AI is that it removes work and creates this post-labor society, right? And on its face, that is really interesting, but in in reality, what we've seen is that when we make it easier for a company to do work, what they do is they remove work for the people who are doing it and transfer all of that wealth and leisure to the people who own the companies. So what makes AI any different? I don't think that's really the can of worms we want to open, but it is a thing to think about, right? Is like, how do we actually mitigate that as we are working with these new tools to, automate things that used to have to be done by hand? Well, somebody's not going to get that work anymore. What does that mean? Like, does that mean that I automated that work and I put an extra 15, 20 bucks an hour in my pocket and like that person can go kick rocks? Or are we actually building a post-work society that, means that like, I don't get to keep all the wealth when I replace a job. That wealth goes back in, right? Like, the whole tax the rich thing. That's deep rabbit holes that we can get down and that are probably not worth completely derailing this podcast. I want to make sure that we have plenty of time to actually build. So one quick note, you mentioned a minute ago about cars and people being afraid of them. And so I dropped a link to a podcast, and it's a very incomprehensible link in the chat. This is a show called The Dollop that's run by comedians, but they did this deep dive on the history of women in transportation, and it is bonkers. Like, if you want a really funny but also very depressing hour of entertainment, listen to that and all the different ways that people used to tell women they would die if they got on a bike, if they got on a train, if they got in a car. Like, it's fascinating how weird we are about all of that. Okay. I have one question from the audience that I want to bring up in the context of this. So you said that, AI is going to sort of start changing and shifting jobs. In the future of web dev specifically, what do you see the impact of AI being?
So yeah, it's a good question. So I see a lot, especially at the moment in kind of the space we're in now, sorry, copywriters, but I think a lot of that is gonna is probably going to be kind of taken over. There are models and like specific sort of train models that will write code for you. I still don't think that they're quite there. Mm-hmm. But for me at the moment, it's more about kind of increasing the productivity. So like Copilot is a good example where you still have to do the thinking up front, but it can kind of do the quick stuff for you. So if I start typing, I want to do a fetch request to get information from this URL. These are my headers. It's going to be JSON. You can either put in a comment and kind of do that the work up front, and then it generates it for you, or it will do it kind of autocomplete. But for me, the actual the important thing there isn't the code that gets generated, it's the thought that goes behind it. So I think instead of writing like sort of let's say 50 lines of code an hour, you can write the kind of specification for the code, have it write 200, 300 lines of code for you in an hour, and then it's up to you to just kind of test it. And things like generating like unit tests for your code is like you say, like I want it to do this, and this. These are the conditions, and then you can kind of get those generated for you. There's definitely, so I've tried to do it a few times with different kind of different frameworks and different projects. Like, how do I write the code to do this? And really, in the time that I've written the instructions, I might have just written the code. Yeah. So I think there's definitely we're not at a point now where it's going to take developers' jobs, because I don't think the models are kind of ready for that. And there's a lot of kind of back and forth and kind of thinking and reasoning that these models aren't capable of doing. But I think it's gonna speed people up. It's gonna make things more productive. And as we're gonna find out later. So I've written a course for Graph Academy on Neo4j and LLMs. So there's one course on the kind of fundamentals, and there's one which is building a chatbot with TypeScript. So I chose Next.js for that, and I chose React as my kind of two frameworks. And then coming on this podcast, I thought, okay, I'll have a look at Jason's website and see what he uses. Okay, so he uses Astro and he uses Solid. But actually, what I was able to do with relative success was translate the React stuff to Solid and translate the Next.js stuff to Astro. And there's a few little things around it. So I was using like React hooks, and then there was a bit, to kind of convert things over to signals, which was which needed a little bit of further kind of coercing. But through like a conversation with ChatGPT, I was able to do that in probably about 20 minutes.
Nice.
So that's another benefit, really.
Cool. All right, so I want to make sure we have time to actually build. So despite the fact that I have 9 million more questions, I'm going to force us over into screen share mode here. So before we get started, let me do a quick shout out. This episode, like every episode, is being live captioned, and there's a little ticker at the bottom that'll show you where to go find that. And that is made possible through the support of our sponsors. We've got NX, who just joined on this month. Thank you so much, NX. Netlify and Vetsu Code, who've been with me for years, or Netlify for years, Vetsu Code for a while now. Thank you very much to the sponsors for making the show possible. And as always, if you or your company want to continue allowing me to do this, please get in touch, because this is the only thing I do for money now. Thank you. We are talking to Adam. So here's a link to Adam's website, and you can hop on there to see what Adam's all about. And from there, I don't know what to do next. What should my first steps be if I want to? Well, actually, why don't you set the stage on like specifically what we're going to do today?
Okay. So as I mentioned before, like I've got a course on Graph Academy, which is all about implementing a chatbot and building a chatbot. So this is the Neo4j LLM fundamentals. So this is like kind of the high level stuff. And what we're going to do is we're going to jump into that chatbot TypeScript course.
Okay.
So the course is kind of written. So I've built an application in Next and React. And what it does at the start is it basically just echoes the response back to you. So as some people say with GenAI, it's a parrot. It just repeats back to you what you've told it. It kind of does the same thing. But what we'll do is we'll go through and do it in Learn with JSON style. We'll take that chatbot. We'll first connect to an LLM, and then we can start to build out some functionality from there and kind of explore what you would do to get started.
Great. Okay. So you sent me a repo that I cloned over here, and it looks. I mean, it's like there's a handful of things I haven't seen in here before. Like, I've heard this name, I haven't really tried it or anything. But yeah, so we've got an Astro site, we've got langchain, which I'm going to ask you to explain in a minute. Cheerio is for tests, right?
So Cheerio is it's kind of like a jQuery thing, where it's basically for kind of scraping, reading HTML into objects.
Oh, okay. Right. Yeah. Marked is for Markdown. Neo4j is for Neo4j. We've got Solid, we've got Tailwind, we've got TypeScript, and I mean we're off to the races, right?
Yeah.
All right.
Yeah,
So if I start this up, let me start this app here. We've got the standard Astro 4321. Okay. So I'm in here. We've got the Langsbot. So this, you said this is right now, it's an echo chamber. So if I say, why are you copying me? It will just repeat what I have to say. Let me zoom in a little bit so this is a bit easier to read. Okay, so this is fun. Where do we go from here?
Cool. So if you head back to the repo, so there's an API route handler, I think you probably call it, called chat.ts. And you can see what this does. So it uses a set timeout to wait for a second and then kind of respond back. So what we'll do is we'll replace this with interactions with an LLM. And to do that, we'll use LangChain. So LangChain is a framework for building AI applications. So I have no affiliation with them other than they're brilliant to work with. So yeah, so it's a and congratulations to LangChain. They've just got their first round of funding, I think.
Oh, cool.
So it's it shows that kind of things are taken off. So it's primarily they were working with a Python library for a while, and then they've kind of moved over to JavaScript as well. So us front end full stack developers can also have fun with LLMs. We don't have to leave it to the Python developers. But really, it's a kind of a orchestration framework for communicating back and forth with LLMs. So if you go to, I think it's if you go into the docs, they've just changed their website, so I'm not quite sure where things are now. But if you go to
the TypeScript docs, right? JSTS docs.
Yeah. So I'm looking for models. So model IO. So basically, the nice thing about LangChain is that they have out of the box support for every LLM provider you can think of. So that's all the way from OpenAI, open source ones, Olama, things like that.
Okay.
And then they started out by doing like building some like sets of classes that you could like instantiate with some config, and then it basically did all the work for you. So it's like a QA chain. So it's like a you put in some information, and then it does all the magic for you. But what they've released recently is this LSAL, or LangChain Expression Language, and basically all those classes were doing under the hood, where they were doing some kind of pre-computation, putting the information into a prompt. So that prompt was sent to an LLM, and then they would pass on the response.
Mm-hmm.
So the kind of newer approach is to kind of do that. And I was kind of scared when I first saw this, because I thought initially like I can do anything with this. Like I can do a Cypher QA chain for Neo4j, and all this gets done for me, and it generates a Cypher query, and then it gives you the result back. But really, actually, all it does under the hood is just like information goes into a prompt, and then that goes to an LLM.
Okay. All right. So I understood what you said academically. Practically, what do I do with it?
Cool. The first thing to do is npm install LangChain, and that will give you your package.
Okay.
And then
I think right. So we've got LangChain, and I already ran the install.
Mm-hmm. Yeah. And then it's just including things from the package and going from there. So in LangChain, you have this concept of a chain. So that's kind of a sequence of events that happen.
Mm-hmm.
So like to me, this feels a little bit like RxJS, if you're familiar with that. But it's basically things piping through from one thing to another thing. And then the terminology has kind of been carried over from the Python library, because so in the Python library, you just use like a pipe command, and then you can pipe things from one thing to another. So like in your shell, whereas that doesn't really get supported in JavaScript or in TypeScript. So there's a few different ways to go through it, but basically you create what's called like a runnable sequence. Okay. It's a sequence of events that execute one after another. Things go from one thing into another thing, and then you go from there. And apparently I've just thumbs up. I don't know how I did that. But yeah, so in order to, have I frozen?
Well, I can still hear you, but you have frozen.
Okay. And what a bad way to freeze as well. Right, I'll see if I can sort this one out while we're talking. But yeah, so basically the way you get an LLM to do what you want it to do is you give it some instructions, or you give it what's called a prompt. Yeah, tell me about it, silly technology. So basically you're given instructions to an LLM. So that could be as simple as like ask it a question, then it will generate an answer for you, or you can get it to
There you are. Oh, did that one just freeze too?
Yeah, I think so. Sorry about this, viewers. And yeah, it could be as simple as providing just a simple instruction. So, can you answer this question for me? Or it could be something more complex, like as a something, you need to do something. So something happens. So yeah, the way we do that is through a chain. So the example that I've got in the course is like a actually let's kind of take this back to where we're going. So what we want to do is to implement that chat interface. So when a question comes in from the user, we take the message, we take the response, we pass that through to an LLM, and then we get that to provide an answer.
Okay.
Cool. So in the root handler, you get a JSON response sent through in chat.ts.
Chat.ts.
Yeah. So you see that input is request.json.
Yes.
So on there, there'll be a message key. So that'll be a string. So actually, if you open it up in open up the inspector, you should be able to see what's coming through.
In here. Wait.
Yeah. Yeah. So if you go to like the network tab, that's it, and then send something through. So it's basically a simple message through with one key, which is message. And the UI is expecting the same thing back. So it's expecting back a message key, and then it'll add it to the response. So what we need to do is we need to create a prompt. We need to pass that through to an LLM, and then we need to pass the response somehow.
Okay, so what that means then is we need to create a prompt. What was the next thing?
Pass that through to an LLM.
Pass to an LLM, and then return the response.
Yeah, yeah. Or
okay.
So you pass the response that comes back.
Okay. Okay. So, first part, creating a prompt.
Yeah. Let's say, let's pretend that this chatbot is you. So what we can do is we can create a prompt template, and what a prompt template is it's basically a string of text with placeholders in there. So you could say, for example, tell me about country name, for example. So let's try that first. So if you do create a new const, and then call it prompt equals, and if you do prompt template, yeah, so capital P, capital T, that's it. Yeah. And then dot from template.
Okay.
And then put some put a string in there, and then so this is where you start to provide instructions. So you could say so you give the LLM a role. So you can say, you are Jason, the host of the Learn with Jason show. Answer the user's question in a how would you describe your communication?
Chat, how would you describe my communication? What if you were gonna say he always responds in a very grumpy, serious way? What are the words you would use? Let's see. Just respond with boops. Let's see. So I would say helpful, friendly, lovely way. Thank you. And a corgi way, like it. Okay. So random and impulsive. Roger, how dare you? Okay, so I've got the description here. Then what do we say?
So what you're doing here is so in essence you're describing a role or a persona, and you're giving some instructions. So you could say so now if you add a new line and say if you just put in curly boys and curly braces, just question. Yeah, so this should be enough to kind of give you give the LLM enough instructions of what to do. So you're saying, you are Jason, the host of Loma Jason. Answer with a helpful, friendly, loving way. So you could do something like include emojis, things like that, or kind of like control how the output comes. And then what you're saying is basically. See if we can do this in a different way. No, it should be fine. So yeah, you're telling the user out to answer the question. So if you put question in front of it with a colon, actually, so you're kind of saying this is the question part of the prompt.
Okay.
Cool. So yeah, what we need to do is to take the information from that request and then inject it into that prompt.
Okay.
So in order to run something in LangChain, you use a runnable sequence.
Okay.
So if you return, if you type return to return something from the root handler. Oh no, sorry. So if you do const chain equals, so you create a new variable called chain, and then so if you do runnable sequence dot from. Yeah, and then this gives you like this allows you to define the steps. So the input that comes in is you have like the message there, which is that input dot message thing. So the first thing you want to do is to do an array first.
Okay.
Empty array. Yeah, and then you start to kind of define and build things up. So let's say what you can do is you can pass through an object. So if you use the curly braces again to kind of start to define what this input would be.
Okay.
And then inside there, if you do, so what did we put question, didn't we, in the in the prompt? So if you do question colon, so this would be a in this case use a runnable pass through. So if you do new runnable pass through, and I'll explain this when it comes through.
Pass through is the one I wanted.
So runnable parallels, you can do these things in parallel. Yeah, and what that's saying is take the information that's passed through to that chain, and then assign it to the question variable. So what we can do actually at this point is you're a TypeScript fan?
Sure.
Okay, so that runnable sequence.from has some generics on there, so you can define what the input of the chain will be and what the output of the chain will be, and this will make it more make your code more robust. So if you after from use the arrow brackets, yeah, and then inside there, so the input will be a string. So if you do string, and then colon, and then string again. So comma. String. So you're defining what the input is and what the output is. So the input going in will be a string, and then the output will be a string. So that's now going to complain that the output isn't a string, which is fine because we're still going from there. So if after the after the braces and the comma, add a new line, then do prompt. So what this is doing is it will pass the question through into the prompt, and it will use everything inside the object that you've defined above to replace those keys with the placeholders that you've got in the prompt. So next thing we want to do is we want to pass that through to an LLM. So we need an instance of an LLM. Now we could go fancy, and we could use open source ones, and we could download Olama, but I don't think we've got enough time for that. I've given you the OpenAI API key, so you can use that.
I have not actually added those to this project. So
okay.
So you gave me like 2 sets. I'm putting all of these together in one end file?
Yeah. Stick them all.
Okay. let me pull this off screen here for a second, and I'll get my .env set up. Okay, that is saved and closed, and .env changed, restarting server. There we go. Let me get this back over here.
That sounds promising.
And there we go. We're in business. I just added everything into this .env here. All right, so now we're ready because I have all the API keys in place.
Cool, perfect. So yeah, we need an instance of an LLM. So underneath the prompt, if you do const LLM equals.
Wait,
oh no, sorry, under the
oh right,
under
right,
the
up here.
definition of the
That
prompt,
makes
sorry.
sense.
And then new OpenAI. So if you start typing OpenAI, yeah, that's the one. And then so that takes an object as the first parameter.
Okay.
And then the key is OpenAI API key.
Okay.
And that needs to be assigned to import.meta.env. I think was it secret _ OpenAI _ API key.
Copy it out of here.
Yeah, but basically what we're doing there is we're defining the API key to use. I hate saying under the hood because I'm not American, but under the hood. Under the hood.
Under the bonnet? Is that the?
yeah, under the bonnet. Yeah, so there's a basically it's just an API call, REST API call. So OpenAI is got a follows like the Open API specification. But really all that's doing, and there's different language models, and you can use those to send to wherever you need to go. So like I was saying, like it supports like 80 plus
different LLMs.
Yeah, different LLMs and service providers. So you can swap one out for another just by having a different instance. So if you wanted to use, Claude from
Anthropic or
yeah.
Okay.
So you would just do that, and it's just the abstraction on top of it.
And then I just oh look, I toss it in and it's not mad at me anymore. Yeah,
perfect. And then what you need to do is to pass the output that comes back. So there are different output passes, but you can, for now, if you use or create a new instance of a string output parser.
Okay.
And you can just do that after the LLM inside the sequence.
Okay, so I do new string output parser. All right. Does it need any args?
No, that's good.
Okay. And so I probably don't need to simulate a delay anymore.
Yeah. Yep. So instead, what you do now is you do chain.invoke.
Chain.invoke. And do I have to await any of this stuff?
Yeah, you will have to. Yeah, so that's an async function. And then if you assign that to, let's call it message.
Okay. And I assume I have to pass in the input.message.
Yep.
Okay.
Yep.
And so I pass this.
Find message above, so that's where it's giving you the.
Maybe we call this one response.
Yeah.
Okay. So just to walk back and kind of recap what's happening here. So we write a question. That question gets sent to this endpoint, and we pull out the message here from the input itself. Then we create a chain, and we invoke the chain using the message. So I guess we can just use that message directly. And that message goes into this runnable sequence, gets passed in. So the runnable pass-through, just whatever shows up here, gets stored as question. That question gets put into the prompt where it gets used here. And we set the tone for how I should respond, or how the LLM should respond as me. We then define the question, and then we pass it through to our LLM, which in this case is OpenAI. And finally, we tell it to say whatever comes back from the LLM, pass that out as a string, which we then get in response. So I should be able to response.
Yep. So if you do message colon response, that'll be the output that the AI, the UI is expecting.
Okay.
Cool. And that should be it. So now, fingers crossed, if you go back into the UI and then ask it a question.
All right. What is the correct number of boops? Uh-oh.
Oh.
Did I?
Oh, so you may have to like stop and start the server. I found this when I was
Okay.
experimenting. But yeah, double check that key as well.
I mean, the key is right because I copy pasted it out of what I set. So we should theoretically be okay. Correct number of boops. And I'll copy that in case it doesn't work this time either. Hey! There is no correct number. It's totally up to you and what makes you happy. Some people might like 1 boop, other might like 100. What's most important is you're having fun and enjoying the boops.
Yeah, there you go. So
I had my doubts, but that does sound exactly like me.
Yeah, actually, it's really interesting that you say that, because in my kind of experiments, I've been trying to kind of like to see what we use. Like, should we use a local LM and stuff like that? And when I used Llama 2, which is Meta's, I don't think it's quite open source, but it's freely available.
Mm-hmm.
LLM, it started to say like, YARL and stuff like that, which is almost the way that you speak, which I thought was quite interesting. So it's always like a parody of what you would
Sure.
do.
Sure.
But one of the things that I've done with my with like when trying to generate like course content and stuff like that for Graph Academy is that I try to say like, communicate in the style of somebody, and I always choose Malcolm Gladwell because I like the way that he talks. But even then, it doesn't ever give me like what I want.
Okay.
And it kind of gives you like a parody of what's going on. So yeah.
Got it. Okay.
But yeah, so that's our first call into the.
But so this is going into OpenAI without any vector embeddings, right? So this is not like I don't know, like what is your opinion on Quick? Right. So this is sort of a just like incorrect kind of nonsense answer.
Yeah.
So if we wanted this to actually be based in like what I would say, how would we go about that?
So this is so I guess there's kind of two things to look at. So firstly, for the kind of tone, you would want to fine tune a model and to like retrain on your communication style, which is something I've to be honest, I have no idea how to do it. But then the other way to do it is to so using embeddings through a technique called RAG, or retrieval augmented generation. And to be honest, I don't really like the term, but it was coined by, I think it was Google AI Labs.
Okay.
Which it's quite funny because the acronym for that is FAIL. Oh no, sorry, Facebook AI Labs. Yeah, anyway, it's basically a way of improving the generation of text, or generation of something based on the retrieval of information from a data source. This could be an API, it could be the world's leading graph database. Yeah. There we go. Yeah. So someone email me, free t-shirt. But yeah, it's basically like taking information from a certain place and then putting it into the prompt. So there's the technique is also called prompt stuffing, but you basically the easiest way for you to do it is to stuff things into a prompt.
Okay.
So we basically change the prompt and the way that we want the user the LLM to act.
Okay.
And then we go from there. And that the way we do that is through, or the easiest way to do that, I should say, is through vector embeddings.
Okay. How would one go about doing that in this case?
Every service that offers an LLM will also have a some sort of vector embedding model.
Okay.
And what you do is you take text and then you convert it into numbers. So in true Blue Peter style, so the Blue Peter is a show from the UK. There was always like they make something through crafts. And here's one I made earlier. Inside the modules folder, and then inside the ingest folder, I've got some scripts in there. So if you go into, I think, into the utils.
Okay.
So basically, there's some scripts in there that basically scrape your website. And I'm sorry, Jason, but they scrape your website. Take get the information from the HTML using Cheerio, and then convert it into an object format. And then what happens is when we've got an individual episode, it will then go and get the text. So I think I think it's transcript, const transcript equals.
Oh yeah, you go and get
so
the transcript.
Yeah,
with all my very helpful naming and my markup.
Yeah, definitely. It was a challenge, especially with the I can't remember what it was, like the title or something. There was like a weird, I guess, like an Astro generated class there.
Oh, or it may have been in the so the way that Astro works is it scopes styles by appending a hash, and so that is so that you can you can basically target like an H1, but it's scoped to the component that uses it without bleeding out into the global document. But it does make it a little tough for things like web scraping.
Yeah, definitely. But I mean, we got there in the end. Basically what you do is you take text, and then you will then want to turn it into an embedding, which means that you can compare it to other things in the way that computers like to compare things, right? This is where we come on to a topic of chunking as well, because this is an important thing. Because when we want the LLM to answer something based on context or based on the information that we give it, each of the LLMs has its own like token limit. So I think it's something like 7,000 for OpenAI. So if you wanted to send all of the information through, like from a transcript and a prompt, it just wouldn't. It wouldn't work because there's too much information. And plus, the more information that you put into a prompt, the more likely it is that the LLM will get confused. And I need to turn off this thumb thing because I think that's what made it crash before. It's what's made it crash. As
a little aside, if you go to your menu bar, there's like a green camera, and if you pull that down, that's how you turn the reactions off when you're on screen. Oh no, did we lose? We just lost Adam all the way. Hey, there you are.
As much as I want.
Perfect. Excellent.
Where was I? Yeah. So you have to basically chunk the text into sizes that are big enough to allow the LLM to answer the question or perform the task that you want it to, while being small enough that it doesn't blow out the token limit and doesn't confuse the LLM. And also remember as well, the more tokens you send, the more money
expensive it is. Yeah. So as a question here, when I do something like vector embeddings, I'm converting my text. In this case, you're going through all the episodes on the Learn with Jason site and grabbing the transcript. So that is megabytes upon megabytes of information. So you're not sending all of that with every prompt, because that would be, there's no way that would fit. So like practically, what is happening that's being sent in with the prompt? Like, is the prompt, you're not sending the stuff with it, but the vector embeddings are there so that it's including that data in every response without having to send all those tokens?
Yeah. So basically, what will happen is, and in langchain, the term for this is a vector store and then a retriever, so retrieving information. But what the langchain library will do is it will take the let's take a step back, right? So we first take the content and then we embed it. We create this embedding, and then we can decide on chunk sizes and experiment. We have these lists of floats in the database. When the user asks a question, there'll be some there'll be some like pre-processing to take out the stop words and things like that. And then basically give you the like if you're asking what is the what's your opinion on Quick or whatever the question was before, there'll be some pre-processing to say, opinion of Quick would be the response, or the actual intent. So there's some, like, I guess, I don't know if it's deterministic or if it's just strictly just removing stop words. But it will then take that phrase, convert that to an embedding, and then use the embeddings in the database to compare it to that to find the closest things. So in terms of the actual like chunk sizes and what you do embed, different length questions responds better or worse to different lengths of like questions and chunks. So there's no right or wrong answer. It's all trial and error basically. But yeah, you basically have a set of numbers that you compare to another set of numbers that then gives you probabilistically, something close to the question that you asked, and then that gets put into the prompt as something to help the LLM to answer the question.
Okay, I kind of think I understand what you're saying, but let's implement it, and that might help clarify. So you have scraped the Learn with JSON site. And I assume because you've got this written that you've already like created a vector embedding of the site somewhere.
Yeah.
And so that's part of the API keys I have.
Yeah. So it's the same API key to create the embeddings and to use that service. The reason that I did that before coming on the show is that this does take a long time, and you hit rate limits as well, especially with OpenAI. I'm not sure exactly how many there are, but I think I probably hit the rate limit after about 50 episodes, and then had to keep, because like 300 something episodes you've done?
Closing on 400 now.
Okay. Wow. Oh yeah. So I had to kind of do it in stages.
Got it.
But yeah, it's a manual process, and one thing I've still not got straight in my head is that if you I don't know if you realize that that there was something wrong in the captions or something like that, you update the text. You have to update the embeddings as well, which means you have to kind of go away, do that whole
you need
process
like
again.
you need some kind of like, this is where I want to learn something like ingest, because there's a sort of like sequential thing, like if this then that, but it's very programming driven. Okay, I got it. All right, I'm ready. So we have all the raw ingredients. So prior to the show, you scraped the Learn with JSON website, you turned that into vector embeddings that are OpenAI friendly, and you stored those in Neo4j?
Yep.
Okay.
Yep, that's right.
So I see a lot of people talking about vector databases, and is a vector database actually different, or is it just a database where you've put the numbers from the vector embeddings?
So it's a way of storing those vector embeddings in a way that maybe wasn't possible at the time when the company existed. So the parallel that I draw with it is that you've got full text search, which has been around for years, and you've got Apache Solr, you've got Lucene, which is used in Neo4j. But then you've got this company called Elastic, and Elasticsearch, and it's full text search plus services and features and things that go around that. And that's the way that I see vector databases and kind of vector database companies being. And if somebody wants to correct me on that, I'm happy to be corrected. But The one example that I've been kind of playing around with like at the weekend was Weaviate. And it's basically a vector database, and it's an NoSQL database with a GraphQL API on the front. So you send your documents up, and then so instead of having to do the embeddings yourself, then I think they do it for you. And then they've also got GraphQL resolvers for generating content. So you can say, like, from this information that I've requested, run this prompt against an LLM which has been predefined. So it's adding the extra information on top of that. But
so kind of what we're doing here, you would configure right on the database itself.
Yeah. And so from a Neo4j point of view, it's looking at the benefits of the data store itself for answering certain questions and doing certain things. I'm sure we'll come on to it, but there are certain things that the vectors don't perform well at. The model needs a little bit more help with, and there are things that it's brilliant at. But it's
all right. So in the interest of making sure that we get to a working final product here, we got about 15-ish minutes left. I want to actually use this now. So you've got vector embeddings in Neo4j. We've got the langchain chain set up. We've got our prompt going into OpenAI. We're returning that to the browser. How do we get the vector embeddings into this chain?
Right. So the first thing we do is we create a vector store. So if you do that under the LLM, so const store equals
store. Okay.
Vector store is fine. Yeah. And then if you do, let me double check. So it's you're looking for an instance of the Neo4j vector store.
Okay. Is that do I create that as a new?
So it is. Just checking my notes. So it's await Neo4j vector store.
Await.
Yeah. And then from existing index.
Okay.
So I've already created the index. So there are ways in LangChain to create things on the fly, and you could just pass and load documents, create even like an in-memory vector database. But then obviously you have to kind of do that every time you start the
Sure.
app. But this is the way of using a vector database that already exists in Neo4j. So the first thing is that we need is an embedding model. So I've used the OpenAI embeddings for this. So if above that you do create a new variable called embeddings, and then that'll be a new OpenAI embeddings. And it should be the same config as the LLM, so the OpenAI API key.
Okay.
Cool. So that's the first argument of the store.
Okay.
And then the second is an object with the configuration. So you need a URL, which is the import.meta.env.neo4j URI.
Neo4j URI.
I think it might be. Do you have to prefix it with secret as well?
Great question. Let me double check here. Yes. Yeah. Okay.
Cool. And then if you just cast it as a string, because it's not set up in the or like as string.
Okay.
And then if you copy that line down twice, so you're setting the username and password.
Okay, username and password. And then this one was username and password. Okay.
Have you stopped your stream? Oh, there it is. Okay, cool. Cool. And then there's a few extra things that we need to put in there. So we need to put in the index name.
Index name.
Yep. So that'll be episode-parts, all lowercase.
Episode. Oh, like a string.
As a string. Yeah.
Episode dash parts.
Yep.
Okay.
And then the so we need the. Do we need it? No, we don't. So yeah, if you do No, it's fine. No, that should be fine. Sorry. Cool. Right. So that's our store.
Okay.
And then we need a retriever. So a retriever is like a layer that sits on top, which is a way of like interacting with it through langchain components. So if you do const retriever equals store.as retriever.
Like that?
Cool. Yeah. And this is where the magic starts to happen. So inside the chain where you've got the question.
Okay.
So remember that takes the value that's been passed through to the chain and then assigns that to a question. If you add a new line there.
Inside the object?
Yep.
Okay.
Yep. And then let's call that context.
Context.
And then if you do retriever and then dot pipe.
Wait, something's wrong. Expected one arguments. Okay.
Yep. So in there, if you just do like a function that takes one argument and then converts it to does like JSON.stringify.
Okay, and so it would just be like
whatever
value or whatever.
Yep, that's fine.
Okay.
And then what that will do is a little bit of magic. It will take the input, pipe that through to the retriever, which then creates the embedding. Goes away to OpenAI, creates the embedding, looks in the vector store for similar things, and then returns back. I think it's like 5 or 10 results by default. And then yep.
Is context like a magic thing, or do we need to reference that in our prompt up here?
Yeah. So you need to reference that in the prompt.
Okay. And then
yes.
Do we just drop in context?
Yep. Yeah. So what you can do as well is you can say like provide an instruction to say only answer the question using this context, or using the provided context. And then it won't fall back to its pre-trained knowledge, and then you're basically using it as a natural language generator. I don't know whether you have to move it above, but I've found that it kind of helps.
Okay.
Yeah, and that's pretty much all you need to do. So if you go back to the chain, one thing I wanted to kind of call out was see that dot pipe, and then the val. The stringify bit. When you add something into you pass something into a prompt, that will need to be a string. So what this is doing is just converting that into a string. And it turns out that, especially like GPT 3.5, GPT 4, they're pretty good at understanding JSON. So that's the easiest way to do it. You can convert it into XML. You can, do it.
Got it. So this is effectively a JavaScript object that we're turning into a string, and we're just dumping in like a stringified JSON object, and it's like, this is fine.
Yeah.
Okay. So is that it? Like, are we ready to give this a shot?
Yeah, let's give it a go. And I'll cross my fingers again, and then hope that when I do that, my camera doesn't freeze. But and I feel like I answered this one.
So see the appeal of using a framework that offers all the benefits of JavaScript without downsides of page weight and duplication. Okay, that makes sense. What sets Quick apart is its focus on improving the user experience without requiring a lot of extra effort from the developer. And as Mishko mentioned, hey, we got name drops. It's all about making it easier to build web apps and lowering the barrier of entry for developers. So if you're looking for a framework that prioritizes performance and ease of use, I would definitely recommend giving Quick a try. That's a pretty good answer. I want to try something and see what happens. I'm going to say, cite your sources, because that should theoretically also link to the episodes. Okay.
Yeah.
What do you think about Astro? Hi there, Fred. Thanks for asking about Astro. This is great because it immediately assumed that this is a plant. Like, this is Fred asking the LLM about. Let's see. From what I've seen so far, it seems like Astro is a really unique take on web development and front-end architecture. I love how it combines the best of both worlds and makes it easier for developers to create fast, dynamic websites. I also appreciate that it's open source and focused on sustainability. That's an interesting take, but can't wait to see what else you all have in store for Astro. All right, so this is like just shy of like, it makes sense, but it's a little bit of word salad. It's kind of like a politician's answer.
Yeah. So this is where, so if you ran that question like 4 or 5 times, you would get a different answer every time. And that's just the way that it works. Like there's a degree of randomness. So there's a temperature, which I can't remember what the default value is, but basically that's the amount of randomness that gets injected in. So the first thing you can
funny
do,
that it's like, this is definitely Fred.
Oh, maybe did you have a Fred in one of the?
I've had Fred on the show a couple times, yeah.
Yeah, so
but it is very funny that it's taking it that way.
So it's almost like a jailbreak from your database. So the data in the database is, and again, this is like the database getting confused because of the information sent through. It thinks that it's Fred. I'm interested to see how this one.
Let's see. As a host of Learn with Jason, now appeals to authority, I have seen firsthand the power and potential of graph databases. Hey, it knows it's a graph database. That's promising. Neo4j is a great choice for tackling complex data relationships and solving graph-based problems. However, as with any technology, there are limitations and trade-offs to consider. For example, the write performance may not be as high as other databases for extremely high throughput scenarios. But even in those cases, Neo4j can still be used in combination with other databases for a powerful solution. Overall, I'm very excited about what Neo4j has to offer, and I encourage you to explore it further. Happy coding. I like that it's ending with happy coding. Like I've been saying that. I've been saying happy building a lot.
Okay, so that's something you can add in as part of the prompt, is that you end it with one of these phrases or something like that. So one thing that I don't particularly like is that it's not really citing the sources.
Right.
But so if you head into the back to the repository, and if you go into modules and then retriever, yeah, the index, that one. Right, so this is my experiment before. So this won't work if you're on X. It's using Olama, so it's using the Mistral model. But if you scroll down a little bit further, so you can see that retrieval query. What that's doing is that's controlling the response. So it's a little bit of cipher to say that. So there's no context on the chunks themselves, but this is like a technique called parent and child kind of matching. So you match on the smaller the smaller chunk, and then you provide information from the bigger one. Mm-hmm. So if you just take that whole retrieval query property and then paste it in to the other one, you should get references as well, because it's got the title, description, year, and the date. But before you leave this file, if you scroll down a little bit further, this is the prompt that I wrote for you. So it's kind of giving information about you, what you've done before. And I actually asked ChatGPT to describe you, and then copied and pasted the information in. And then there's basically a little bit of fine tuning there on the prompt or it was called like prompt engineering, to actually work out like the extra things to kind of add personality, and also to make things more consistent.
Do not attempt to answer any questions that don't relate to web development. That seems like a good idea. Remember to use episode URLs, titles, and descriptions to provide. Okay, so this is good. So then if I head back to this page and you said here, mm-hmm. and then I also want to include some of what you said here, because I think this is really good. Actually, why don't we just throw the whole thing in here and do it the way you did it and see what happens. So here is, so my little bitty prompt up here got us decent results. Let's see what happens when we give it a well thought through prompt.
Yeah, and so this is also like a bit of a trial and error thing, and like some of this information might be extraneous, some of it might be needed, but it's all about kind of experimenting, changing the prompts until you get what you're what you want. I'm confused as to why it's returning, like it's doing it in like a like monospace. I don't know if
that is interesting. I think it might be coming back as like Markdown and having too many spaces at the beginning for whatever reason, because it only does it sometimes, which is really interesting. But yeah, so as the host of Learn with Jason and an experienced developer, I'm delighted by Astro's potential to revolutionize web development. From my conversations with Fred Schott, as opposed to directly speaking to Fred Schott, I can tell he has a deep understanding of the needs and challenges of the developer community. I've seen firsthand how Astro brings people together in a joyful, collaborative environment, and I'm excited to see where it goes from here. If you want to learn more about Astro, check out my interview with Fred on Learn with Jason here with an actual link to an episode. That's pretty dope. Okay, so then let's see. Tell me how I can use Neo4j. Starting out with the course App Development with Node.js on Graph Academy. Oh, interesting. This course covers how to get started with Neo4j in a Node environment, driver session transaction type systems. You'll receive a badge upon completion, provide some incentives. You can sign up for the Neo4j sandbox, and nice. So this is like, this gets way into like Neo4j itself and doesn't link to like the episode you were on where you gave us this information. Let's see, tell me what your, or let's see, let's test it. What is your favorite cheese? My favorite cheese is the one that the chefs love more than anything in the world. As I mentioned in the episode, oh my God, I actually provided information about this. This is amazing. Oh my God, this is incredible. Oh, this is really good. This is really good, actually. My favorite cheese is the one that is made with love and passion. That's probably something that came out of my mouth in the past. Let's see. How many boops is the proper number of boops? Subjective and can vary based on personal preference. In the context of the lesson, we're using a variable called boop count. This can be changed to any number desired. It is only for demonstration purposes and does not have a specific number of boops that is deemed proper. I like that this, through providing the embeddings, we have gotten a bot that absolutely will not give you a straight answer. It depends all the way down, which is probably the most accurate version of me that you could get. Yeah, so we get into the actual episodes. This is, all right, so this is very cool. Like, I think this is, it's good to see. And I think like a way that I would probably use this in practice is there are a lot of instances where I know I had a conversation with somebody and I can sort of remember, like I don't remember what episode it was or exactly, you know, what we were talking about. I just know that they said something super smart. And if I were to say, you know, like I quote Sunil Pai all the time on this quote, that silver bullets only work on werewolf-shaped problems. That quote, I remember. I've had Sunil on the show several times before, so I don't know which episode that was. I would love to be able to say, like, what was the episode where, you know, somebody said something like this and get quotes back, and being able to pass in those, like have the vector embeddings so that we can get a decent chance of actually finding the information that's not like in the title or description, but something that somebody said in the middle of the show. Or a general, like what is Jason's general take on like software architecture would be really interesting to see. And to me, that's like, I feel like that's a great, like there's search, there's filtering, and then there's like conceptual search where like there was a vibe here. Can you find anything that gets into this general subject matter and give me a list? And I think that's really, really cool.
Yeah. So there's this, there's it's a good kind of comparison of like Google versus Perplexity. Sorry, so Perplexity is like an AI search engine, and when you search for Google, you search for full text, which is if you know that exact quote, or you know a certain part of that quote, if you know part of the lyrics of a song, you can find the song based on the chorus, because those words appear within a certain distance of each other. If you can't remember the quote itself, but the quote is something like, give a man a fish and he'll eat for.
Right.
What? Give a man a smash
Exactly
burger
what
and
you just
he'll
did.
eat
Can
for
you
a day.
Google that? Who knows?
Yeah. But it's the semantic search and the semantics behind the text which is important, and that's what the embedding model can understand. So even if you're talking about a certain thing, or you're talking around something and not using those exact terms, it should be able to find it for you.
Awesome. All right. Well, I have more questions, but unfortunately we're out of time. So I'm going to instead just ask, for somebody who wants to go further on this, where should they go next? I'm going to drop a link to this Neo4j chatbot, because what we did today is sort of an expansion on what this course will teach, right?
Yeah.
So anybody who
100%.
wants to build effectively exactly what we did today, if you go through this course, you will get a result very similar to what we did, with obviously whatever embeddings you want.
Yeah, well, I mean, you'll get better ones, because there's an extra module down at the bottom which is about cipher generation. So the I guess one thing that's really important to kind of leave people with is that embeddings are really useful for certain things, and the kind of questions we're asking are perfect for that. And actually, an example that I've got is I was playing around with the embedding the syntax FM. Sorry to mention a competitor, but mentioning
Definitely not a competitor. Friends.
Friends. Okay, cool. In that case, yeah, I guess this is all about friends, really. But there was an episode with Salma Alam-Taylor, so friend of the show.
Yeah.
And she was talking about DevRel, and she made a joke about limousines.
Okay.
And it was something like, I now drive a limousine to work, and I asked the chatbot, which is pretty similar to what we've got here, was she joking when she said that, or what did she say about limousines, and was it a joke? And it worked out what the quote was, where it was, and told me actually it probably is, based on the context of the conversations and the window of text either side, that it's probably sarcastic. It was probably a joke. So it's brilliant for stuff like that, and it's for like the qualitative stuff. It's brilliant for. But if I asked if you asked the chatbot now, how many episodes mention Neo4j, it wouldn't be able to answer it, because it's doing like a similarity search on certain things, and it's basically finding the next best set of results, or the nearest neighbors. So even if there's something that's not necessarily as similar to the result, it will return that anyway. Gotcha. And it's up to the LLM to actually decide whether that answers the question. Whereas if you can write, so it's text to cipher for Neo4j, text to SQL, all these kind of libraries. If you run something on a data source, and then so one of the lessons is give me the average rating for a movie, or something like that. If you want a quantitative result, a finite result, then that gives you you have to get that through other means. So that's either talking to an API, having some sort of logic. So developers aren't going to disappear, because someone's going to have to write that logic for the LLM to use. But yeah, and then there's to answer your actual question now. So if you take that course, and there's the Neo4j and LLM fundamentals, which is the one before that, which is a kind of a precursor to it, which teaches you everything that you need to know. That will teach you all about semantic search, which is pretty much what we've done today. Cipher generation, so using an LLM to generate a cipher statement that will retrieve the information and put that into the prompt to answer the question. And then the next step beyond that is agents. So this is where LangChain becomes really exciting, because you can create an agent where an LLM is responsible for choosing a tool for you. So you can say, define a tool that should be used in a certain context. So for qualitative stuff like comparing movies by a plot, recommend me movies for ghosts, then you can use one tool, which is like the vector retriever, or you can define another tool for a quantitative thing to say, go into the database and actually find me this stuff, or like go to an API to find out what the weather is in San Francisco and stuff like that. So that's like the next level stuff. And then the level on top of that is there's a tool in LangChain called LangGraph, which is nothing to do with Neo4j and graph databases. But what that allows you to do is to define a set of tools and a state, and then the LLM kind of reasons with itself. So it builds up like a memory and a set of messages. So you can say like, solve me this problem with these tools, and it will go away, do something, come back, and then it will look again and it will do something else, and it will keep going back and forth. So like you're in danger of spending a lot of money on OpenAI API bills, but like it's like that's the reasoning that the LLMs itself can't do, which I think is amazing. That's really exciting.
That's very cool. And I would love to keep going all day. Unfortunately, we're out of time. So I'm going to do one more shout out. This episode, like every episode, has been live captioned. We've had Amanda here from White Coat Captioning all day. Thank you so much, Amanda. That is made possible through the support of our sponsors, NX, Netlify, and Vetsu Code. Thank you all for making the show possible. And while you're on the show, make sure you go and sign up on the schedule, because I haven't put the new shows up, but I promise they're going to be a lot of fun. I'll have them up this week. So you can get in the Discord, get on the newsletter, just subscribe here, whatever makes you happy. Also, if you're on Twitch, YouTube, etc., please do subscribe to the channel, hit the like button, share this with your friends, because that helps me continue making more of these shows, and it really does mean a lot. So thank you all very much. Adam, thank you so much for spending some time with us, and we will see you all next time.